super volcano would kill
Okay.
almost all of us. The Yellowstone super volcano, it's a caldera volcano. Like they didn't realize that it was so big until somewhere in like the 2000s, I think it was. They did satellite imagery and they realized, oh my God.
On the Indonesian island of Sumatra, the Toba supervolcano exploded with incredible force 74,000 years ago. This eruption caused fire, famine, and death to a quarter of the world. Toba threw out enough debris to cover an area the size of the United States, burying huge parts of Asia under burning ash that spread across Lake Malawi. Scientists today are still finding clues about the Toba eruption, as it is the most devastating eruption mankind has ever known. There are theories that the event might have even plunged the planet into an ice age, with only 1,000 individuals believed to have survived the incident. How exactly did this happen, and what triggered the eruption at Lake Toba? Lake Toba volcano had the strongest eruption in the history of the human race. Little is known about supervolcanoes today, and far less was known 75,000 years ago. So, since no one could tell the warning signs at the time, it must have been an unpleasant surprise from nature, a regular day gone sour. Hot ash clouds moved at 320 kilometers per hour. The eruption formed a caldera 100 kilometers long and 30 kilometers wide. The blast was powerful enough to vaporize mountaintops. About 2,800 cubic kilometers of ash, pumice, and lava were ejected. The pyroclastic flow killed everything in its path instantly. The magma from the eruption could cover California with 30 meters of material. Ash from the eruption spread over an area of at least 20 million square kilometers, reaching as far as India and the Arabian Sea. Breathing in the post-eruption air caused suffocation, leaving a harmful mixture in the lungs, killing the victim in an instant. A great number of tribes perished along with their culture and history. The thick ash from Toba flooded the islands, heavy enough to collapse buildings and clearing all in its path. Lake Toba's ash poisoned water sources immediately, and its effects reached far beyond Sumatra. To say this eruption started in New York City, spreading ash across Houston, and affecting wildlife in the Gulf of Mexico would only be a close estimate. The Lake Toba incident spanned 7,000 kilometers, with deposits from Toba found at the North and South Poles. Ancient Homo sapien, or close species, like Homo floresiensis, habiting the area, living locally, directly witnessed the carnage. Entire forests died in central India because of the super eruption. Toba was so extreme, it spewed enough ash to create a decade-long volcanic winter that premised up to 1,000 years of cooler-than-normal temperatures, leading to massive die-offs of vegetation and the end of some species. Global temperatures were said to plunge by up to 15 degrees Celsius. According to the Toba catastrophe theory in the early 1990s, it was believed humanity touched extinction. Scientists researching the incidents received boxes of volcanic ash from many different people. These samples came from widely separated parts of the Earth's surface. When the scientists examined the volcanic ash, they found that the chemistry was very similar. This similar chemical composition suggested that all the ash came from a single volcanic eruption. Usually, ash from a typical eruption does not fall more than a few hundred miles. However, these identical ash samples were collected from over 4,000 miles away. If a single volcano caused all this ash, its eruption must have been more powerful than any in recorded history. Researchers have gone as far as developing specific computer models to understand the effects of the Toba eruption, and their findings revealed shocking truths. Ancient human teeth were found in Sumatra dating back to the Lake Toba event. Not just that, Genetics researchers working with human mitochondrial DNA also discovered what appeared to be a genetic bottleneck occurring between 50,000 and 100,000 years ago, suggesting that nearly all humans perished in its volcanic winter. This claim was fueled by examining the Mount Tambora eruptions, which shook things up for a year despite being just a fraction of the size of the Toba blast. Nevertheless, there are good reasons to think the scenes weren't as extreme as the Toba catastrophe theory suggests, with some studies tagging the report exaggerated, claiming that ancient humans weathered the Toba supervolcano just fine. One strong argument against the theory was premised on magma. Depending on the volcano, magmas are capable of holding very different amounts of dissolved sulfur and carbon dioxide. Sulfur dioxide can stop the sun's radiation from reaching the ground, and would be one of the key components for a volcanic winter, the type that can cause a massive population dip. However, chemical analysis of Toba's ash suggests that its magma can't hold much sulfur, and that means Lake Toba's blast probably has less effect on global temperature as the theory suggests. Researchers also investigated sediment cores from Lake Malawi in East Africa and found crystals and glass from the Toba eruption in these cores. By examining microscopic plant matter in the cores, researchers could study vegetation levels 100 years before and 200 years after the eruption. They discovered no cooling or massive die-off occurred in the area. This was the first research showing direct evidence of the Toba eruption's effects on vegetation just before and after the event. And according to the researchers, the Toba eruption did not negatively affect vegetation in East Africa, except for alpine regions. The sediment cores indicate that the volcanic winter either never occurred or was too mild to be recorded in the sediment. Another study reported that early humans were thriving during the post-Toba period. Archaeologists sampled sediments at 2 sites in South Africa: Pinnacle Point, which is a series of coastal caves, and Vliesbaai, an open-air site. They found evidence of the Toba eruption at these sites. Using optically stimulated luminescence, a technique that shows the last time a grain of sand was exposed to sunlight, researchers confirmed that these sites were occupied during the eruption. The findings revealed that the Toba eruption did not disrupt human occupation at these sites. In fact, human activity increased after the catastrophe. It was the first time researchers were able to show what humans were doing before and after the eruption, and the humans appeared to be doing well during this period. Not all experts agree with these interpretations, though. Some experts argued that layers of sand above the ash indicate climate change at Pinnacle Point and a decrease in population, but the data sets from previous researches would seem to complement each other and suggest that the Toba supereruption had little effect on Africa's climate and its human populations. The main difference between the studies would now lie in how these researchers interpret the magnitude of climate change caused by the Toba eruption. Africa and its human populations were largely unaffected by the eruption. Some sites in South Africa served as refuge, where human populations survived by exploiting the food-rich coastline. If this is true, researchers hope to find other coastal sites where human populations persisted during the long, dark winter. This research is important because it helps scientists understand how ancient humans responded to environmental challenges. It also provides insights into the effects of large volcanic eruptions on climate and ecosystems. Findings show that early humans were resilient and capable of adapting to changing environments, even after one of the most significant volcanic eruptions in history. These findings provide a new perspective on the Toba supereruption and its effects on human history and their environment. As the Toba eruption, once thought to have nearly wiped out the human population, now appears to have had a much smaller impact on human survival and adaptation. However, Lake Toba is not the only supervolcanic eruption in history. Lake Taupo in New Zealand also erupted on the North Island about 26,500 years ago, a timeline that's even more recent than the Toba event. However, the huge difference between both super eruptions was that at that time, there was no record of life in the surrounding area of New Zealand. Now, as we examine the eruption and aftermath of the greatest supervolcano known to the human race, we must have a mental picture of what makes them dangerous. Volcanoes are simply fire-breathing mountains, and there are over 1,000 of them on Earth. This fire-breathing action of volcanoes are known as volcanic eruptions, and about 50 eruptions occur every year. For example, in 2021, the Cumbre Vieja volcano in El Paso spewed lava in an event that lasted 3 months. Burning molten rock flowing down toward the sea destroyed around 3,000 buildings, entombed banana plantations and vineyards, ruined irrigation systems, and cut off roads, but no injuries or deaths were directly linked to the eruption. The volcano fell silent after flaring for 85 days and 8 hours, making it La Palma's longest eruption on record. The Spanish government valued the loss of buildings and infrastructure at more than $1 billion. After months of eruptive activities, volcanologists were able to certify that gas, lava, and tremors had subsided in the Cumbre Vieja ridge for 10 days and thus declared the volcano's apparent exhaustion. Spanish Prime Minister Pedro Sanchez called the eruption's end the best Christmas present. Supervolcanoes, on the other hand, are massive volcanoes that can produce extremely large and powerful eruptions, tens of thousands times that of a typical volcano. These eruptions can release volcanic material, like ash and lava, into the atmosphere, spanning thousands of cubic kilometers. When a supervolcano erupts, it can cause widespread destruction and have a devastating impact on the surrounding area, damaging ecosystems and impacting agriculture and food supplies. The ash and gases released can block sunlight, leading to a drop in temperatures and causing a volcanic winter, thereby disrupting weather patterns on a global scale. Supervolcanoes are rare, and very little is known about them. In fact, there are only thought to be 6 supervolcanoes currently, with some well-known examples being the Yellowstone in the United States, Lake Toba in Indonesia, and Taupo in New Zealand, with the most popular being Yellowstone. Scientists use a volcanic explosivity index, or VEI for short, to measure eruptions, and the scale runs from 0 to 8, with 8 being the realm of super-eruption, as in the case of Lake Toba. One thing that might surprise you is that being a supervolcano does not guarantee a super-eruption. Although these fire-breathing rocks are capable of global-scale catastrophe, the reality is that supervolcanoes don't normally blow at full capacity. Yellowstone in the United States, for example, has erupted over 100 times, but only 3 qualify as a supervolcanic eruption. The VEI measures the amount of debris a volcano hurls into the air in cubic kilometers, and the scale is quite linear. If an eruption was tagged a VEI 1, you'd have eruptions that span 0.001 cubic kilometers, while VEI 2 eruptions cover up to 0.01 cubic kilometers, VEI 3 is 10 times more, and so on. It is at VEI 8 that we begin to enter the realm of supervolcanoes and super-eruptions. The general rule of thumb is the higher a volcano's VEI, the more devastating its eruption would be, and at level 8, we're talking over 1,000 cubic kilometers of catastrophe. To fully understand the extent of what took place at Toba, let's consider some other historic eruptions. Let's start with the lowest possible volcano rating, one with a VEI of 0, like those recorded in Hawaii, spilling lava all over people's lawns. Even at 0, that eruption still manages to be destructive. Another eruption that you probably heard of is Mount St. Helens, that happened on May 18 in the United States. Mount St. Helens blew its top, laying waste to 250 homes, flattening 600 square kilometers of trees, and killing 57 people in the process. It's a huge leap up the Volcanic Explosivity Index scale, and was termed the deadliest, most destructive volcanic event in US history, but was galaxies below the Toba blast as the eruption spanned exactly 1 cubic kilometer, the lowest possible for a VEI 5. With the force of around 200 megatons of TNT, a VEI 6 eruption in Krakatoa on August 27th destroyed over 2/3 of the island, generated massive tsunamis up to 40 meters high, and caused over 36,000 deaths. The explosion was heard as far away as Australia and the island of Rodrigues near Africa. As significant a leap as this is from Mount St. Helens' destruction, it's still at least 100 times less comparable to the Toba event. Now let's talk about a VEI 7 eruption. These events are so rare, there's only been one super eruption of this size recorded. The island of Sumbawa in Indonesia, Mount Tambora, erupted on April 10th, ejecting an estimated 160 cubic kilometers of material, initially killing 10,000 people and causing massive tsunamis in the process, destroying the homes of 35,000 more. The eruption had profound impacts on the climate, agriculture, and society worldwide, with the ash cloud spreading, blocking sunlight and leading to the year without a summer in the following year. The aftermath caused global crop failures, food shortages, severe climate anomalies, and polled 80,000 more deaths. By now, you probably get a picture of what happened at Lake Toba, because the Sumbawa event, though surpasses the Krakatoa incident in destructive aftermaths, is still at least 10 times less than what happened in Toba. You might have also noticed that all 3 eruptions took place in Indonesia, something the country owes to their geographical location and probably can't do anything about. As we wrap up this story, one question comes to mind. Could it all happen again? Could another supervolcano potentially set us up for another decade-long winter? Or if you'd prefer a comforting question, can we stop super eruptions for good? NASA claims to have found a lasting solution to these super eruptions, and their solution theoretically looks like what might work. NASA scientists, using Yellowstone as their model, estimated that the 35% increase in heat transfer out of the magma chamber would stop it from ever exploding. To achieve this, one would need to drill down into the supervolcano and start pumping in high-pressure water. And with every passing moment, more heat would be extracted until way over 100 years of continuous water flow. The magma would be cool enough to end the threat of an eruption for good. Sounds feasible to you? As for a Lake Toba re-eruption, there's no guarantee nature is done with unpleasant surprises there. We can't really say for sure that these supervolcanoes, 3 of which have been mentioned in Indonesia or anywhere else, won't erupt for certain. 90% of the Earth's earthquakes take place in Indonesia because loads of faults crisscross the landscape. One of those faults, the Great Sumatran Fault, runs directly through Mount Toba, and if the Sumatran Fault ever becomes particularly active, it could reawaken Toba's dormant magma chamber and will not just be staring at a massive earthquake, but also Toba's potential re-eruption. Like the last time, we might not get very much warning before that happens. Even if there's enough time to evacuate, the eruption would still be devastating, as Sumatra is home to nearly 60 million people and is about twice the size of Great Britain. Evacuation or not, millions of people would be displaced. Kuala Lumpur and Singapore being less than a tenth kilometers away from Toba, considering its 7,000 kilometers journey from the last eruption, may as well be built right on top of the magma chamber. While anyone within 100 kilometers of Mount Toba would be dead, no matter in the event of a re-eruption, what happens next would depend on whose side the wind is. The Homo floresiensis from the last eruption was barely impacted thanks to the wind blowing all the ash away from them. If a re-eruption were to occur and the wind favors mankind, blowing the ash cloud out to sea, then we might see our civilization continue to exist. In a different scenario, the rest of Indonesia would first see carnage on an unprecedented scale, before the aftermath deals a big blow to the global economy, one that might rival the COVID in impact. Trees and crops would be killed as the ash fell down, animals would die by the millions from ingesting toxic chemicals, water supplies would become undrinkable, electricity lines would come crashing down, escape would become impossible. It would be a colossal disaster, wiping out untold numbers,